19.3, and this lesson is using the OR rule for probability. And to help with the OR rule today, I'm going to show you another way to solve a problem involving OR. So let's start with problem number 2. And in this problem, we are at a vegetable display at the market. There are 48 apples, there are 36 oranges, and in this pile of 48 apples and 36 oranges, 2 of the apples are rotten, 2 of the oranges are also rotten. And we pick first an apple, then we pick out an orange, and we want to know what is the probability that the apple or the orange is rotten. Okay, a little bit different than the last lesson where it said and. And rule and the OR rule are very different. So let's take a look at what this looks like in relationship to a tree. So I'm going to get a blank page here. And so we have a nice big space. So we're going to start by selecting an apple. Now, either my apple is rotten or my apple is not rotten. There are 2 rotten apples out of 48, which means there are 46 non-rotten apples out of 48. All right, so probability of picking a rotten apple is 2 out of 48. The probability of getting a non-rotten apple is 46 out of 48. All right, now I'm going to select an orange. All right, so either my orange is rotten or my orange is not rotten if I pick a rotten apple first. If I pick a non-rotten apple first, my orange that I pick could be rotten or the orange that I pick could be non-rotten. All right, so let's talk about probability. The probability of getting a rotten orange is 2 out of 36. There's 2 rotten oranges and there are 36 oranges. That means the probability of it not being rotten is 34 out of 36. And the probabilities here are the same. A rotten orange, 2 out of 36. Non-rotten is 34 out of 36. Now the question, if you go back and read, is what's the probability that I get a rotten apple or a rotten orange? So we're going to go down and we're going to check each pathway where either the apple is rotten or the orange is rotten. All right, well, here's a path where both the apple and the orange are rotten. So that satisfies the conditions, either the apple or the orange is rotten. Here's a path where the apple is rotten. And here's a path where the orange is rotten. Now, I'm not going to check the last path because neither the apple nor the orange are rotten. So I have 3 different paths, and I'm going to find their individual probabilities, and then I'm going to add them together. So the probability of getting a rotten apple and then a rotten orange is 2 out of 48 times 2 out of 36. The probability of getting a rotten apple and then a non-rotten orange is 2 out of 48 times 34 out of 36. And then the last path is 46 out of 48 for a non-rotten apple multiplied by 2 out of 36 for a rotten orange. All right, so we're going to go down and we're going to multiply each of these. And we're going to add those individual probabilities together. So let's start by multiplying them first. We'll get a product and then we'll put that in. the sum of those three. So we have, in our numerator, we have 1 plus 17 is 18, plus 23 is 41 out of 432. So 41 out of 432. All right, now, second way of doing a problem like this is using the OR rule. And by the way, let's go back here. We could have set all of this into the calculator in one shot. We could have just put parentheses around the top. We could put this in parentheses, plus this product, plus this product, and that would have given me the answer of 41 out of 432. So it's a little bit faster way to do that in the calculator. But using our OR rule, the OR rule says to take the probability of event A, that would be the probability of getting a rotten apple, and the probability of event B, that's a rotten orange, and then we're going to subtract the probability of event A and the probability of event B, and that gives me the probability of event A or B happening. So the probability of A getting a rotten apple is 2 out of 48. The probability of getting a rotten, this should be a B right here. There we go. The probability of the second event is getting a rotten orange, 2 out of 36, minus the probability of event A is 2 out of 48, and then getting a rotten orange, 2 out of 36. That would be the probability of having both of those events occur. And that gives me my probability of one or the other. And so if we go ahead and put this into the calculator, we can begin with 2 out of 48 plus 2 out of 36 minus, and then in parentheses, 2 out of 48 times 2 out of 36. Oops, I put something in wrong. Let's see what I did wrong. All right, I noticed I have a 3 out of 36 up above instead of 2 out of 36. So let's put that back in. Oh, it's not going to let me do that. All right, we'll just try it again. That looks better. And there we get our solution of 41 out of 432. Number 4, the spinner is spun twice. What's the probability that will land on a number greater than 9 the first spin, or a number less than 6 on the second spin? So we're going to use our probability rule for OR. First, by taking the probability that first event A is a number greater than 9. So there are 3 numbers that are greater than 9 out of a total of 12 numbers. Plus, the probability of event B is a number less than 6. A number less than 6 would be 1, 2, 3, 4, 5. There are 5 numbers less than 6 out of 12. And then we're going to subtract the probability of event A and event B, 3/12 times 5/12. find the probability of choosing a pyramid from the first shaded set, a pyramid. So let me just circle those. Whoops. Okay, first pyramid. And then get a cylinder from the second set. And I said the word and I should have said the word or, I'm sorry. Or get a cylinder from the second set. So probability of getting a pyramid from the first set or a cylinder from the second set. So using our OR rule, the probability of getting a pyramid is 3 out of 2, 4, 6, 8, 10, 12, 13. Plus, the probability of getting a cylinder is 4 out of 2, 4, 6, 8, 10, 12, 13. Minus the probability of the first event and then the second event. Okay, to help us with number A, we're going to do a tree diagram again. And in this tree diagram, we're going to go to the next page. So might want to write this down very quickly, and I'll transfer this over. We have 6 blue, 8 white, 4 green, and 2 brown socks, and they're in a drawer. We're going to pick out and we're going to remove. So that word remove tells me that I'm going to not replace. When I take one out, it's not going back in. I'm going to remove 2 socks from the drawer, and I want to know the probability that the first sock will be blue or the second sock will be green. So we're going to use the OR rule, and we have to remember that these are dependent events as I remove things and I'm not replacing them. So let's start out with a tree diagram. We insert a blank page here. And here's what we have. We have 6 blue socks. There are 8 white socks. I'm going to abbreviate here. There are 4 green socks. And there are 2 brown socks. Okay? So on my first pick, I have 6 out of 20 chance of getting a blue, 8 out of 20 chance of getting a white. On my first pick, 4 out of 20 of getting a green, and 2 out of 20 for brown. If you add 6, 8, that's 14, plus 4 more is 18, 19, 20. So there's my first pick. All right, my next pick, my second pick. I can either pick blue, white, green, or brown. Now, let's just go back, and we're not going to check anything yet. Go ahead and put our other choices here. On my second pick, blue, white, green, or brown. All right, now the question said, what is the probability of the first sock being blue or the second sock being green? First blue, let's go ahead and check off all the ones where the first one is a blue. This is one where the first one is a blue. All of these pass here have my first pick being blue. Or my second one being green. That would be this one here. Second one is a green. Second one is a green. And second one is a green. So I've checked all the pathways where the first sock is a blue or the second sock is a green. So I can go through and find the probabilities of each one. So let me go ahead and put in now my second probabilities. In this case, if are now only 5 blues left in the drawer out of 19 socks. If I pick a blue and then I pick a white, well, there's still 8 white socks, but there's only 19 in the drawer. A green sock. There are 4 green, but only 19 in the drawer. And a brown sock. There are 2 brown socks out of 19. Okay. If I first pick a white and then a green, well, there are still 4 green in the drawer, but there are only 19 because I pulled 1 white one out. And if I pick a green sock first, and then I want to pick another green sock, I just have to remember now there's only 3 green socks out of 19. And then if I pick a brown sock first and then a green, well, there's still 4 green. If I pick a brown first, there's still 4 green out of 19. So we're going to find the probabilities of all of those. And so I'm going to use a lot of parentheses. So my first probability is 6/20ths times 5/19ths. And then I'm going to add all the remaining ones. 6/20ths times 8/19ths. Plus the next one, 6/20ths times 4/19ths. And then plus 6/20ths times 2/19ths. And I'm going to keep going, plus 8/20ths. I'm down to my white now, 8/20ths times 4/19ths. Plus, I'm down to my green, 4/20ths times 3/19ths. And finally, 2/20ths times 4/19ths. So we get 83 out of 190. Now, if we use the addition rule, as they have right here, all we have to do is remember a couple of things. Number one, the probability of getting a blue, that would have been 6, there's 6 blues, 6 blue out of 20. And then the probability of getting a green second, now this is just getting a green on its own without any other givens. So the probability of just picking a green is 4 out of 20. Minus, now the probability of a blue and then a green, we have to remember to drop this down by 1 because we're not replacing it. We don't drop it down by 1 here, we drop it down by 1 inside here. So the probability of getting a blue is 6/20ths times the probability of then getting a green, given that I've already taken out a blue, is 4 out of 19. Okay, so my OR rule, I always have to drop down in the second fraction. All right, so if we use this rule, let's see if I can move this over a little bit here. I can get all of this over to the right now. And then we can put this into the calculator. Just remember, these are the 2 things that are a little bit tricky here. And that's why I showed you the other way first. So 6/20ths plus 4/20ths minus the product of 6/20ths times 4/19ths. And there we get our 83 out of 190. Alright, we're going to use the counting principle to determine the number of possible outcomes. And we're going to spin this spinner 6 times. 6 different times. Alright, and so the first time there are 6 outcomes. time I spin it, there are still 6 outcomes. And there are 6 outcomes each time I spin that 5 times. And the counting principle says to multiply all of those different outcomes. So in our calculator, we're looking at what 6 to the 5th power is. So there are 7,776 different outcomes for spinning that spinner. All right, number 12 is saying you're going to spin each spinner one time, and they want to know what the probability that just the first 2 spinners land on a 1. We don't care what the last one lands on, but we want the first 2 to land on a 1. So this is now, we have to decide, is this an and or is this an or? So what I'm doing is I want to get a 1, and then I want to get a 1, and then I want to get anything. So we're going to use the and rule, a 1 and a 1, and then any number. So the probability of getting a 1 on the first spinner is 1 out of 6. The probability of getting a 1 on the second spinner is 1 out of 4. The probability of getting anything here is 12 out of 12. And we multiply the product of all 3 of those. And that should give us 1 out of 24.